Hello everybody, welcome to this construction estimates video. We'll be looking at building up the rate for concrete, 20 megapascal concrete. So let's get on with it. 20 megapascal is basically the target strength for this particular concrete that we will be pricing. So we're basically trying to look for the price of this concrete with this specific target strength. So let's start with the introduction. As you can see in front of you, when a client initiates the idea of a construction project, they will need to know the cost of the project and a feasibility study is undertaken. So as we know from previous videos, I think the first video that I made, the client is the one who starts the idea of the project, is the one who presents the idea to the experts who will be working on that particular project. Let's say, for example, a restaurant owner wants to open a branch and they need to build a restaurant there in that new area where they're operating in the new market. So they are the ones who start with that idea of wanting to build that restaurant, and that's how the project is birthed. That's how it comes to life. So this ensures, or this is to ensure that the project will be economically and viable, and that it fits the client's budget and requirements. That's very important. That's why we need to estimate these things. However, it is not easy to come up with the exact cost of a project. Instead, we estimate the cost of the project, and to accurately do this, we have to use a rate based on the market prices of individual parts and units of measurement. We can say maybe dollar per square meter, or pound per cubic meter, yen per kilometer, euro per bag, or many other types of units of measurements that we'll be dealing with, depending on the part of the project that we're dealing with. Let's say if it's a road, we'll be using kilometers. If it's cement that we're going to be looking at in terms of this example, we'll need to do it in bags. We need to charge it in bags because the suppliers sell it in bags. If we need maybe the tar that's used on the kilometer of a road, we need to price it according to the unit of measurement that is used in the market to sell that tar. So if it's maybe tons, you then charge it in tons. Like concrete is charged in tons. So that's another unit of measurement for the mass of the concrete. So let's move on. The most common professional estimators in the construction industry are quantity surveyors. As we know, they're the ones who prepare the bill of quantities, and also they deal with the other costs like prime costs and provisional sums and preliminaries and generals, all these other costs that may arise pre-construction, during construction, and post-construction stages. So those are the main people who estimate, but we can have other people like engineers as well, structural, civil, electrical. They can also estimate according to their own. If you look at tender documents, you have bills of quantities from these different types of engineers. And then also the people who oversee the projects, like construction managers, project managers, they also have some competence in terms of estimating. They are proficient and also competent in that, and knowledgeable in that sector of estimating. So these are the people that we know in the construction industry who are estimators, but the main estimator is the quantity surveyor in a project, because they specialize in the pricing and the quantifying of things in the project. So let's move on. In this video, we're going to be using the unit rate estimating method, which requires us to do a quantity takeoff of individual components of an item and calculating their respective rates. Then combine the rates to come up with the final price of a single unit or part of the item. So the unit that we're dealing with here is not necessarily the unit of measurement, but we're looking at a certain section of a whole thing. Like let's say it can even be in terms of the units of measurement, like a square meter of a wall, maybe 230, 345, 115, or whatever type of wall you're looking at. You just look at a square meter, you price whatever materials are in that square meter according to standards. That's why we use rates, because the rate changes according to the different types of projects that you're dealing with. You can deal with maybe a story building, multi-story building. You can deal with a common residential building, maybe in a high density with some stands are 400 square meters, or even medium density or a low density with 2000 square meters, depending on the land and also the space that the project is occupying. You need to find the smallest quantity of that whole, and then you price that small quantity, and then you multiply it with the entire quantity or the entire item. So that square meter of a wall, you then multiply with the walls that are on that building, because they have the same material, they have the same composition of those materials. They're not just the same, but they're also in the same quantities all around. So you just multiply with the rate, and then you get the total price for that project. So it's an easy way of doing it, but as you can see, there's another alternative, as you're going to see just now. So the alternative is operational rate estimating, which focuses on pricing the work as a package and not pricing from its individual components. So when you do your quantity takeoff for the quantities that you're dealing with, you have many dimensions. Either you'll be dealing with square meters, so you need length and width. If you're dealing with cubic, you need length, width, and height, or depth. If you're dealing with circular plan, maybe you need the pi r squared. Depending on what you are dealing with, you need the radius, and then you square it, and then you multiply with the pi, or say 22/7, or 3.142 by that radius squared. So you are just basically dealing with the different components first, but you're not pricing the each component like what we are going to be doing. You are going to deal with each individual component in terms of calculating its quantity, and then you add all those components together. So you add the walls, the foundation, the superstructure, the roof structure, and all the other parts of the building. You add them all together, and then you price the entire unit. You're not going to price from the different parts of that unit, or the different parts of the whole thing, of the entire work that will be done. I hope I have made sense, but if not, then we'll see as we go the difference. But if you are not understanding even after that, I will try and make other videos to explain more on this operational rate estimating. Just one thing, remind me later on in the comment section if I forget to add some estimations and standards and constants on the Shumafoot blogs, so that you may be able to refer to them as you do your calculations. But these ones that I'll be putting on the blogs, they're not based on a certain or a particular standard of a certain country. They are going to just be for Shumafoot, so they are just hypothetical, just so that you understand what we're going to be dealing with. They're going to be based on Shumafoot, not any other country's laws. But what you're going to be dealing with in this example is basically what's common in Southern Africa. Yes, so just know that the standard that we're going to be using is based on what's common or what is used in Southern Africa. So as you can see, next we have the components of the unit rate, or what we use when we're building up the rate. The different components that we use, that we consider, which are the material going to be used for the project or for that part of the project, and then the plant or equipment that is going to be used, the machinery that's going to be used in the process of combining these materials to make the item that we're going to be using in the project, and then the labor that's involved in mixing these materials to make that part of the project, and then the profit for both the contractors and subcontractors, and the overheads for both the contractors and subcontractors. Overheads are basically the costs that may arise during the course of the project, like taxis and the like, just those costs that are indirect, not the direct costs mainly that are really related to construction, but other costs that may also affect the project, like the tax that I was talking about. You're going to see when we deal with quotations, we have what we call value added tax, VAT, and then we have pension funds for the workers. You're going to see that we have to also include that, and then we also have transport and accommodation, whatever, all those other things that we need to factor in, and also bills that may arise, electrical bills when you're going to be using the equipment from the suppliers, and also we're going to need to buy fuel and oil, and all these are the expenses that may arise during the course of the project. They all fall under overheads, but they have to be indirect, not okay. Maybe fuel that I was talking about will fall under the plant and equipment, which will affect that, but overheads are basically indirect, like the bills, the tax, the pension funds, and all the other things that do not really concern construction. And then these components are general, as you shall see and consider. We have to consider the pricing of each of these components. So each of these components, as you can see, they're based on market prices of the materials, and that will be received from suppliers. So you need to have multiple quotations that you refer to, and they have to be updated. because prices are always changing depending on the updates in the industry and also the production that's happening and all the other dynamics that may affect production of the goods. So you need to follow up on that, which means that estimators need to be updated each and every time. That's a very important point to avoid overpricing and to avoid designing things that are out of date, which means even architects, they need to know the materials that are in place so that when estimators are pricing, they don't price with materials that need to come from abroad, because that's an extra cost. Transportation, you're going to see that transportation is another cost. So you have to make sure these things are local or they're locally found. And then you have to also deal with salary, wages, and rates gazetted in the law of a country. They are, if you look into the laws of your country, you'll see that there are certain standards in terms of how workers are paid. The labor laws, even the hours that they work. We have labor laws that deal with that. In construction, is a bit more than with other industries. So you're going to see that the number of hours is just slightly more than the usual. But those are the things that are in the law, so that if you are an employer, you won't be charged with overusing your workers. They are also human beings like you as an employer, but they are employees, but they are also human beings. They also deserve to work reasonably. And we have already looked at pension funds, value-added tax, and all the other costs that we need to account for that may affect the client's budget, because the client, apart from them being the one who initiates the project, they're the ones who are funding. The clients are the ones who fund the project. So we need to constantly update them on price changes in the market and all that, which means that the method that we're going to be using, we need to be able to adjust those prices. But this method is not going to be, as you can see, it's going to be long. It's going to be a long method. That's why this video is not a short. It's a long video you're going to see. But I'm not trying to make it very, very long so that you get bored as you watch. But you have to appreciate each and every component, each and every bit and piece of the calculations and the considerations that we make in the construction industry. So let's begin the video. Let's commence. Okay, so now we're looking at a quotation. This is a formal statement of estimated costs for a list of services, equipment, or materials needed for a particular job, or any of the like. And then the following is an example of a fictitious hardware store called Shumbafoot Hardware. So this is just an example of a quotation, and you're going to see how it's laid out. If you visit hardware stores, you'll find something similar to this, which shows you the prices of each of the things that they are selling. So you need a couple of them so that you can compare the prices. When you're tendering, you need to have cheaper prices most of the time, so that you can have a low cost bid, which will also help you get jobs. Because if your bid is more expensive, and maybe if you are a new company in the industry, then it's going to be very, very hard for you as a contractor for you to operate, because your prices will be too high. But if your prices are too low, at least you realize that you can get a job. But make sure that whatever cheap price you get, it's for a quality product, not just getting cheap price with low quality. You have to ensure that the price matches with even the quality of the product. Okay, so the quotation, we have the date and the customer's name. Usually most quotation documents, they have the customer's name, so that they keep the customer details, so that they keep in contact with their potential customer, or the customer who is going to buy from the hardware store. The good thing is nowadays you can just get a photocopied quotation with all the materials that are sold in that hardware store. So you won't need to come with specifications. You can just get a list of everything, and then you can just select what you want from that list. So this is how it looks like. We have codes. Some hardware stores have codes on their quotations to show the specific code they have given to each and every type of the material that they are selling. It's basically for their own records as the hardware store. And then we have the description of the materials. As you can see, we have industrial bricks, cement, and whatever, with the types that they are sold in. You can just see that specifically. It has to be specified because each type has its own price. We have common bricks as well, which have different price. We have blocks, which have different prices. Some are even made of concrete, which means that the material that is included in that making of the brick and how it's made will also impact the price. so they have different prices. And then we have a quantity, because we're dealing with the rate of that per cubic meter of concrete. We will need at least one, but usually you can just get for one price for one, and then you do your own calculations. You just multiply with the number that you need according to your own estimates, so that you can decide on whether you're going to buy from that hardware store or not. And then we have the unit price, which is the price of that one, the quantity of that material that you're looking for. And then we have 15% tax. That's the current tax for Zimbabwe. So you'll find that in each and every country there are different percentages. Some have 10, can even have 14, some can even have 5%. It depends on the country's laws. So here we're going to be dealing with 15% for Zimbabwe. You're going to see that most of the values that we have are from Southern Africa. So the 15% is what we call the value added tax. So it's what we add on to the price of each and every good or service. So that money goes to the government. According to the laws, it states what kind of goods and which services are taxed. All that is stated in each and every country's laws. So make sure you check for the laws that govern your country on the requirements for that tax, usually from revenue authorities, revenue collection authorities from each and every country. They have those specifications that you can get. And then as you can see under the description and code, you're going to see that it's written, please note that VAT, which is value added tax, is included in all prices. So there's no need to deduct or rather to add. The tax is already added. So it's just a matter of showing what's the percentage that was used in that text column. It's just showing you the percentage that was added on top of the amount. And then we have underneath that we have the quotation will be valid for a certain number of days. Like I said, there's always stocking that happens in the hardware, so they have to stock new materials and the like. They might remove certain materials from their stock, so that will affect the number of days that this quotation will be valid. And also the prices change, so they need to update their prices and also update their markups. So that's also one factor that will affect this quotation that you'll get. So make sure you are always up to date with your quotations. And then even when you're estimating, also be up to date. And then the sales rep will also sign. You need to know who had given you that quotation. These are just formalities to ensure that there's no cheating or misrepresentation happening there. And then delivery, you're going to see later on, that's a very important point. You're going to see later on that suppliers can also deliver their stuff, materials, equipment on site where construction is taking place. There's also transportation fees and all that needs to be paid. So you can check whether it's delivered by the supplier or you have to go and collect, which means that that's another cost that needs to be estimated. That needs to be included in the estimations. And then on the far right, you see that there's the amount, which is the total. After multiplying the quantity and we have the unit price, we'll get the amount. The tax will already be included. It's just a matter of showing you what's the percentage. So I'm just multiplying quantity and unit price to get the amount. So as you can see, it's just the same thing because the quantity we all have ones. We just need for one price for one thing. And then we have the subtotal, which is the total from the amount column. And then we rather know that the total from the amount column, because we said the text is already added to those amounts, we'll get what we call the total. That's the actual total. Then the subtotal is the difference between the total and the VAT in the text. So we need to find the actual price, which is the gross price of the materials, which is $21.40. And then the $3.78, that's the value added tax, which is the money that we add there. And then the net total, which is the total that is going to be used to sell these materials, will then be $25.18. So that's how a quotation looks like. Make sure you understand this document or this statement, which summarizes all the things that you need to buy, that you want to buy. So we need these prices when we're now calculating. So which means estimators need to be in contact with the hardware stores that they're going to get their supplies from, so that they get the prices which they are going to use to estimate the cost of the project, because they're going to be using those hardware stores to get their materials, which means they're going to buy from those stores so that they use those materials on their projects. So they'll need to find out what are the prices so that the client knows that they are going to need to budget for this amount of money for the particular project. I hope we have understood. let's move on to the calculations. Okay, so my assumption is you know how to calculate using proportion those rates. So, or basically just calculating using proportion. I hope that's the case. But if not, I'll try to explain as we move. So we'll start by looking at cement. So our concrete, which is 20 MPa, we are going to realize that there's a standard mixture for that 20 MPa. In order to achieve that 20 megapascals, you need the quantities in the ratio of cement, sand, and aggregate, which is stones. You're going to need with the ratio 1 is to 1.5 is to 3 respectively. Cement, sand, aggregate 1 is to 1.5 is to 3. So that's the ratio in terms of their units or quantities. And then you find that when we add the 3 numbers, 1 plus 1.5 plus 3, we'll get 5.5. So if you know how to calculate with the ratios, we know that cement is basically 1 over 5.5 of the total amount in the concrete. That's the total amount of cement in the concrete is basically 1 over 5.5. That's the fraction of cement in the concrete. So here we're going to be dealing with 1 cubic meter of concrete. That's the unit rate that we're going to be using. So it's 1 over 5.5 by 1 cubic meter, which is equal to 1 over 5.5 cubic meters. So that's our volume for cement in a cubic meter of concrete with the target strength of 20 megapascals. And then the density of cement is equal to mass over volume. That's a common equation. Density is equal to mass over volume, or mass divided by volume, which is equal to 1,440 kilograms per cubic meter. So that's the density of cement in general for our example. And therefore, the mass of cement required for our example we'll then rearrange that equation to become mass is equal to density times the volume. And then we say the volume is 1 over 5.5 multiplied by 1,440 kilograms per cubic meter, and our 1 over 5.5 is in cubic meters, as we see. So the cubic meters will cancel out, and then we remain with kgs, which is the mass that we want, which is equal to 261.82 kilograms. And then one thing we also need to account for in this calculation is allowance for shrinkage and wastage. So as you read in the note below, I'm going to summarize, but you can read the note below. You're going to see that when we add water to this concrete mixture, there's going to be some chemical reactions between the materials that are involved in that mixture. 1 is to 1.5 is to 3, the cements and the coarse aggregate, which in this case we are going to be using 19mm stones, as you saw from our quotation. So what you're going to see is after that, when the mixture starts to dry up, when the concrete starts to dry up after adding the water and mixing, you're going to see that the volume is going to decrease because the things are now bound together. They are now bonding together due to some chemical processes. You can go and research more about that. We have I think silicon dioxide, which makes sand. We have water, which is H2O, and we have cement, which is a couple of other materials, other compounds rather, and even the coarse aggregates, which are the stones. They also have maybe silicon dioxide for some types, and then others have other kinds of compounds within them, chemical compounds, which make up those stones. So you see that there is some chemical reaction that's going to happen when water is added to bond these materials and make the concrete. So when that happens, you see that at first when they were still powder and stones, you see that it was going to be there were going to be some air spaces within them. But when the water is added and they start bonding, those air spaces start to be filled up. They start to be filled up, and that means that the volume of the entire mixture is going to decrease. And to account for that, because that means that it's no longer going to be 1 cubic meter, but we want to price it for 1 cubic meter, which means that we need also to adjust the price. But we can't do that. We want for 1 cubic meter for it to be easier to use as a rate. So which means we need to adjust the quantity of the volume that we're going to be using, the quantity of the materials that we're going to be mixing up to get 1 cubic meter of concrete after shrinkage. So we need to factor in that shrinkage, and the wastage, because you know some workers, when they are working, they don't really focus much on the materials that are being used. That's why they need to be monitored. Monitoring is very important for those workers. So there's going to be wastage. We need to account for that, unfortunately. And then we might even have accidents and all those other things that may cause these materials to be wasted. So you also need to factor in wastage. But we are going to say 5%. Usually you can get for the 10%. But let's suppose we are so particular about not wasting. Maybe our construction company, we are very good at managing our workers, making sure that there's no wastage of materials. So our integrity is to be trusted. So we'll just put it at 5% so that the price for our bid will be a bit lower than for other contractors. That's the assumption that we're going to be having. So if you assume 5% is going to be wasted and 25% is going for the shrinkage, we add together, we get 30%. That's why you get that 1.30. We're going to look at that later. But we have to allow for 25% of shrinkage and 5% of wastage. And usually wastage is lower than shrinkage, but it can be, it shouldn't be higher actually. It should be lower, because wastage, we can manage wastage, but we can't manage shrinkage. It's up to the materials themselves how they're going to be bonding with each other. So we just have to play according to their tune. So yeah, that's how it is. I hope you've understood. Okay, so in that case, we've seen that that's how we get our 30%. And then what we want to find is we are going to be adding that 30% to the 100% that we already have, which is the 1 cubic meter. So we're going to have 30% of 1 cubic meter added to the 1 cubic meter, so that we account for that shrinkage, so that when it shrinks, it goes back to 1 cubic meter. It doesn't shrink and become lower than 1 cubic. We want to ensure that when the shrinkage happens, we achieve 1 cubic meter of concrete. I hope that makes sense as well. So we then say 100% plus the 30%, we get 130%. And then we want to find 130% of the mass that we have calculated, which means we're going to say 130 over 100 by that mass, or we can just say 1.30, which is the decimal for that fraction. And then we get our 340.37 kilograms, as you can see worked out right there. So it's fairly easy. You just first find the volume, and then you convert the volume to mass, and then you convert the mass to bags, which is the next stage. As you can see, the number of bags of cement required to make 1 cubic meter of concrete of grade 20 megapascals, which is basically MPa, is going to be that divided by the mass which we got in the quotation. The quotation, we saw that Shumba Hardware is selling its cement per 50 kgs. So each bag is 50 kgs. So we say 50 into that number, which gives us 8.06 bags. We're not going to round it off to 9 bags, so that we can be able to get a lower bid. We're doing this using the mindset of the actual estimator, this quantity surveyor, who is trying to estimate for the bid for the contractor, because the contractor wants to win the bid, so they have to ensure that their price is favorable to the client. So in order to do that, but you can round off to the nearest whole number, but that also means the price is going up a bit. So that's it. But you'll find that it might affect you if you don't round off as well, because when you now buy, you are going to not buy according to what you calculated. You might need to then buy it as 9 bags. So just to be safe, some people round off, but it's better not to, so that you get the actual figure or the actual price. Okay, then we move on to sand. Same thing, but we know that from the ratio 1:1.5:3, we find that the ratio for sand or river sand by volume will be 1.5 over 5.5, because in our ratio 1.5 is for sand. And then the density of dry sand will be equal to, so that density is for dry sand, is equal to 1602 kilograms per cubic meter. Therefore, the mass for the sand required, we use the same formula as we did with cement, which means we have 1.5 divided by 5.5 multiplied by the density. We then get 436.91 kilograms. And then we also allow for shrinkage and wastage, which is basically 1.30, the 100% plus 30%. And then multiplied by the mass, we then get 567.98 kilograms. And then we find the number of bags required. But remember, according to the quotation we got, they are going to be selling in terms of 40 kilograms per bag. So it's 40 kilograms for one bag. So we're going to divide by 40 instead of 50. That's the specification from the quotation that we got. So that gives us 14.20 bags of sand that we need for this particular for the concrete that we're going to be making, which has the target strength of 20 megapascals, as we see. So that means, as you can see, we need to convert to the mass to get the bags. We could, if we knew the volume, instead of converting to kilograms and all that, we could just go straight to the volume there, and then we divide with the standard volume to get the number of bags. But we don't have that, so we need to convert to kilograms and then find the number of bags according to our quotation. Okay, so we move on to the coarse aggregate, which is the final component according to our ratio, 1:1.5:3. You'll find that we are not going to calculate water on its own because we have already made those provisions in our percentages. So when we talk about that shrinkage and the like, we've already accounted for that water. But water, usually we'll then calculate it separately because we need to then get borehole water. It's better to use borehole water, which is clear and does not have is not concentrated with a lot of impurities. It has to have less impurities or even no impurities at all. That's even better. Drinkable water is most preferable if it's in those quantities that are needed. But borehole water is very favorable. You can use that one to do your mixing of concrete and the like. Why? Because, like I said, we are going to have chemical reactions when we add that water to the mixture of the cement, sand, and coarse aggregate. So which means that we have to ensure that there is no interference in the bonding and in the chemical mixtures and the reaction from the impurities or any organisms. We have to make sure that there are no organisms available or the organisms don't interfere with the chemical processes which happen when there is the addition of water to the mixture. So that we achieve the target strength. That also affects the target strength, so we have to ensure we are using borehole water. So the coarse aggregate, that's what we're looking at next. Without further ado, ratio of the aggregate for the 19mm stones according to our quotation, that's what we're going to be buying. So the ratio is 3. From the ratio we then get the volume is 3/5.5 cubic meters, which is the amount of aggregate in the concrete that will be mixed for the to achieve the 20 MPa. And then the density of the coarse aggregate is particularly almost the same with that of sand, of the sand that we're going to be using. We're going to be using river sand. Pit sand is usually for the mortar because it's a bit sharper, so it's better when it comes to when we are bonding the bricks with the different big bonds, the stretcher bond, English bond, Fleming's bond, different types of bonds. Pit sand will be better. River sand is a bit more smoother, but yeah, that's basically the density of the coarse aggregate that we're going to be dealing with. And then therefore the mass of the aggregate required will be equal to, so the mass is equal to the density times the volume, as we have seen. We do the same calculation, the 3/5.5 by the density, and then we get the mass. As you can see, 873.82 kilograms. And then we go again, we allow for shrinkage and wastage, so we need more of that coarse aggregate as well. We need more of each of the materials, as you can see, so we have to account for that in each and every of the materials that are available, or we can just do it for the total amount of materials that are going to be there. So we just add the totals and then we get, but we can't do that because they're different materials. We have to treat them differently or separately so that we don't have a wrong figure or a wrong price. So it's then 1.30 multiplied by the mass, and again we get 1,335.97 kgs. We divide by the 40 kilograms according to our quotation, and then we get the 28.40 bags of coarse aggregates that we need in order to mix with the other bags of sand and cement to get the 20 MPa concrete. So I hope you have understood this section. Pretty straightforward, and you have to understand that why we are then dealing with mass as well is because we don't have the standard value for the volume, or we couldn't find the volume that we can use from the quotations to find the number of bags for, or we could have just used volume instead of converting to bags. We could have done that, but mind you, we don't have the price for the 3/5.5 and 1.5/5.5 and 1/5.5 in terms of volume. We only have the prices in terms of bags, or in terms of the 40 kilograms and the 50 kilograms, which is the mass. So we have to then convert to bags to get the prices. So I hope you have understood this section. Let's move on to, it should be the summary of the materials part, so that we can then price the materials. Alright, so we then move on to materials. The mix ratio for our materials, as we have discussed prior to this, we saw that it's 1 to 1.5 to 3, cement, sand, and aggregate mixture, respectively. And then we have market prices of the materials, including transportation to site, including VAT. That's very important, because if VAT is not included, we then have to calculate as we have done right at the bottom of that table. As you can see, if it's not included, we then have to add to the total price or the total rate of the materials. So we then find that for cement we have 8.06 bags, which we calculated. We multiply with the rate for one bag, which is a 50 kg bag of cement. We then get that amount, which is $104.78. And then we have sand, the same thing. We multiply the bags and the rate. We then get $56.80. The aggregate, we do the same thing, and then we get our $142. So as you can see, all this is done according to the quotation that we have used, which is from Shumba Food Hardware. You can go to any hardware, you find quotations, and then you use that. But this is just fictitious hardware, so you can just use it as an example. We're just using it as an example. It does not exist. You might find that some of these prices are not the actual price on the market. And by the way, quotations last for a certain number of days. Some people say for a week, 7 days, or slightly more or slightly less, plus or minus 7 days. So you just need to check how many days you need with that quotation, because prices can change. And as you can see, the total number, if we add the amounts, we then get $303.58 or $303.58. So we find that that's the amount of for the rate of the materials that are needed to achieve a cubic meter of concrete. I've used that word achieve intentionally, because we know that we have added 30% in order for us to account for wastage and shrinkage, but we want to achieve the 1 cubic meter of concrete after it dries up. So that's the price that we need to pay. That's the cost for that 1 cubic meter, which means we're going to use this price to multiply with the amount of concrete we are going to be using, in the total concrete we're going to be using for the entire project, either for slab, for foundation, for the story floors and the like, or for even the walls. If we're going to have some concrete blocks for walls that maybe are not precast, that are in situ, we're going to even have lintels. That's maybe the rate that we can use. Or if the lintels need a different mixture, then we'll start again with the target strength that is needed for each and every part. So this is specifically for 20 mega pascals. Okay, so now we're done with the quotation that we're looking at. We're now going to be looking at estimates and constants and standards and laws from the different countries that we are going to be dealing with, or the laws from the different countries that this contractor that we are dealing with is going to be operating in. So you can use your own standards from your own country to apply to this example, so that you get to understand it better. But for this example, we're not dealing with a specific country, but the standards are related to the countries in Southern Africa, to the laws in Southern Africa. And then you find that with plant and equipment, we have concrete mixture, which is going to cost around $100 per day to use. That's the rent for that, and that's going to be including the wet rate, which is including the other expenses like fuel, oil, maintenance provided by the supplier. So which means the client just pays $100. Everything is going to be within that $100. But you will find that there are other suppliers who say, no, we are just going to hire this thing, but maintenance and fuel and whatever you're going to provide on your own. We just want the money for hiring that concrete mixer. And then you're going to see that here we're just going to be dealing with the concrete mixer, assuming that we are going to be using foundations, and we're not going to need a vibrator. There is something that we call a vibrator, which allows for the removal of air spaces within the concrete when it is deposited, to ensure that there is a homogeneous achievement of the bonding of the elements within the concrete. So we have to also factor in that one if it's needed, but in this case we are assuming that it's not needed. That's one thing I also need to highlight. So we are going to see that that's the wet rate. So For our hourly output, we're going to find that we're going to have 1.75 cubic meters that is going to be produced every hour, that's going to be mixed after every hour. And then, like I said, we're going to have 8.8 working hours in a day, which means that's not the conventional according to what most industries or most sectors consider as the working hours for a day. Some will say 8 hours, but here we're going to be saying 8.8 hours. The construction industry is a bit different from other industries. It requires a lot of work, and you find that sometimes there may be delays, and there has to be provision for extension of the program of works or the extension of time for the works, because the scope of the works will have a very big impact on the duration of the project. So you have to understand the scope of works before you plan the duration of the project. Okay, so with the values that we have $100 per day. We have an hourly output of 1.75 cubic meters, and remember, we are dealing with cubic meters, so it's dollars per cubic meter. So we need cubic meters, we need the price per day, and we need the number of hours used per day, because we are going to charge these people we are going to charge the client per hour. This is the equipment that we're going to be using. So we are going to see that we have to convert using per hour. So I then say the price per day divided by the number of hours per day, that's the number of working hours per day, which is 8.8. We're not going to say 24 hours. That's unreasonable. They don't work for 24 hours. So it only works for what? 8.8 hours. That's the number that we're going to be using. It depends on the negotiations. Maybe the supplier will say no, for security and all that, which is the other expenses that we're talking about. For security and all that, there is a need for another fee. So that's another negotiation you make. But there has to be a provision for what? For the price for 8.8 hours. So then say the $100 divided by 8.8 hours, which is basically 1 day, will give us $11.36 per hour to use that plant, with everything included, the fuel, security, maintenance, and the like. And then for our friends who do not understand proportion, I think this is the part where you really be comfortable, because we get to learn it. So using proportion as usual to calculate the rate per hour, taking into consideration the allowance for shrinkage and wastage. Remember, it's 30% is the total. We then say for 1.75 cubic meters per hour, we get $11.36. What about for 1.30 cubic meters per hour? How did we get that 1.30 cubic meters? We are basically saying that's the percentage for the cubic meters. So it's a 130 of 100% multiplied by 1 cubic meter of concrete. That's basically what we've done. That's how we found the 1.30 cubic meters. Okay, so we're basically going to say, okay, so how much is it for the 1.30 cubic meters per hour? The standard that we use is 1.75 cubic meter, but that's not the one we want. So we then say 1.30 over 1.75, the cubic meters per hour, the rates, they cancel out, and then we are left with dollars. We multiply with the $11.36 for per hour, and then we get our $8.44 per hour, which is the price that the cost for using that concrete mixer per hour to achieve the 20 MPa target strength for our concrete. So I hope you have understood that. And as you can see with the notes that comes afterwards, we see in this example we didn't use the vibrator, but you're going to see that the other plants or machines that we are going to be using, even for example, if you rent a wheelbarrow, you will need to also account for that equipment, like wheelbarrows, to transport concrete from where it's being mixed to where it is supposed to be at, for in situ and the like. So I hope you have understood this concept. Okay, so labor, please don't be intimidated by the workings that you're seeing, all these statements and values that you're seeing in front of you. We'll go through them bit by bit, so just calm down and you understand that these things are easy. So to work on the mixing of concrete, we'll need 1 skilled worker and 3 unskilled workers, which we call a gang, which is a group of them. The following are their all-in rates, which are the net rates after factoring in accommodation, transport allowance, medical aid, pension funds, tax, etc. So all those costs that will be incurred as you employ these workers, they will be factored in, which you call the all-in rates. If they are not factored in, we'll do the same thing that we did with VAT just some minutes ago. So make sure you understand that point. So this depends on the requirements stated in the law of the respective jurisdiction. So according to the laws of your country, as we see, we are going to be dealing with what's in Southern Africa, as I had stated earlier. So it depends on that. So you can just check with the laws of your own country on standards and constants and how people are paid, how these workers are paid. So we have these two classes, which are the skilled worker who is knowledgeable in that area. They are tested, these people. That's why you find that there is a builder, for example, and we have assistants who help this builder to do the bricklaying and all that. So we have people who mix concrete, and we expect that that group has a skilled worker who supervises. So we're not going to really charge for that supervision in this example. You might then charge in some other examples, but in this example, we're not going to be charging, so we're not going to include it in our calculations. What we're going to be including is the people who are going to be mixing, transporting, and depositing, offloading and loading this concrete, which are the worker grades, which we call the unskilled workers, the gang of unskilled workers, which are not tested. So they need supervision from the skilled worker. But usually supervision is also paid. Don't get that wrong. These skilled workers, they're also paid for supervising. So we then know that the total for them is $7.20 per hour for the three of them. So which means each one of them will get $2.40 per hour each for doing the mixing of concrete and all these other things. So we then find the gang of three unskilled workers is expected to work 1.70 hours per cubic meter, like we saw with the equipment, of concrete 20 MPa, because we're expecting these hours for us to get that 1 cubic meter. So they have to do it in 1 hour and 70 minutes. So we then find that, however, it's not 1 hour 70 minutes actually, it's 1.7 hours. Correct me if I'm wrong, but I think that I had made a mistake. Pardon me for that. However, we have a provision for shrinkage, which is 25%, and wastage, which is 5%, which will affect the period of work. So the new time the unskilled workers are expected to work is. So when we factor in the shrinkage and the like, it means there's going to be more work, which means we need to also add that, include that, which means we then say the 1.3 cubic meters that we're going to be using. I think I've explained where we're getting that 1.3 cubic meters as that extra 30% added to the 1 cubic meter. And then we multiply by the number of hours that's needed to get that 1 cubic meter. We then get 2 hours and 21 minutes. Yes, so I'm correct. Yes. So 2.21 hours is the amount of time. We have to give them time to mix these things. These are also human beings. They're not robots. So they need time. And you are going to understand that these constants are also factor in the fact that when they are working, they start with energy, they start with ginger, but at the end they become slow, and because they've been working for long hours and they become tired because they've been putting a lot of work. So because of that, they need to rest and all that. So we just need to factor in the fact that they are human beings. So that's why we find that the time is not so short. It's actually a bit long. So we're not guessing where these values are coming from. We know that we want to end up with the amount of money per cubic meter. So that's why we see that we have taken the constant for hours per cubic meter, because we're dealing with the time and the amount they're going to, the unit of measurement that we need, which is the cubic meter. And then we have taken that 1.30 because we are factoring in what? 30% of shrinkage plus wastage. So I hope you are not just confused by where we are getting these values. We have to plan how we are going to be factoring in each of these components. And then therefore the labor costs for mixing concrete, including transportation and placing at the place of need, e.g. foundation, footing or slab, is equal to. So we're going to say that we need $7.20, which is for the 3 worker grades, which we saw per hour. And then we know that we have 2.21 hours, which we have already calculated. So the reason why we calculated these hours was because we have our price per hour. So we needed to find the hours that they're going to be using, that they're going to be working for us to get the price per cubic meter. You see where the pattern is coming from. We already have a constant, which is dollars per hour. So now we need to find dollars per cubic meter. So that's why we went round trying to look for this 1.7 hours per cubic meter and 1.30 cubic meters. It's so that we then achieve the dollars, $15.91 per cubic meter. I hope we have understood that. We need to get that straight. If you practice, you get to understand what I'm talking about. And then if the 3 unskilled workers transport the concrete and deposit to the foundation, then they have to do it at the rate of 4 hours per cubic meter. That's the constant that we're going to be using for this example for foundation. we are going to use for foundation in this example, but if it's slab, it depends. It means that they're going to need more time. And like if it's maybe for lintel, which is above the door or above the window, it also needs its own pricing and its own time. Then taking into account the shrinkage and wastage 30%, we are then going to say there's need for more time again. We are keeping in mind that these are human beings that are working. They are not robots. So we need to extend time. If we extend the material, if we increase the material, it means there's more work, which means they need more time. I hope that's sinking into your mind. So we need that 1.3 by the 4 hours to get the 5.2 hours per cubic meter. And then the labor rate that we then get afterwards using the time that we have, which is 5.2 hours, and then with the rate per hour that the 3 workers are going to be having is going to then give us $37.44 per cubic meter. And then now we want to find the total for the labor so that we can then use in our summary stage. So we then say the $15.91 per cubic meter, which is the cost for making and mixing and transportation. And then we also have the cost of then putting it into the foundation, which is the $37.44. We then add those two values to get both the mixing, transportation, and the placing into the foundation, which then gives us the labor cost at $53.35 per cubic meter, per achieved cubic meter. We are not making 1 cubic meter, we are making 1.3 cubic meters, but after shrinkage and wastage, we're going to achieve the 1 cubic meter, which then costs us $53.35. So now let's move on to profit and overheads. I hope we have understood this section. It's a very important section to understand. Alright, so now we move on to this profit and overheads, which I explained earlier. The profit, we put a markup. The contractor puts a markup on the price that is already calculated from labor, plant, and materials. Then they put their markup, which is what they want in order for them to do their business. And then also the overheads, those are the indirect costs that will be incurred during the project. So we are going to assume that the contractor has placed a markup of 20% to the total cost, which accounts for profit and overhead costs. So they are all included, the overheads and the profit, in that 20%. Therefore, the cost for profit and overheads is 20% of the 303.58 from materials, the 53.35 from the plant, and the $8 or the 53.35 from the labor, and $8.54 from the plant. Then we get our profit and overheads totaling to $73.07. Yes, 7 cents per cubic meter. And then our summary and totals, we then get for materials, we already have the value, plant, labor, profit and overheads. We just list them, and then we find then we add all of them to get the total, which is $438.44 or $438.44 per cubic meter of the 20 MPa concrete. We are saying per cubic meter because we are saying that the 30% was just for us to then achieve a cubic meter. It's not just an increment, but it's just something so that we can achieve that cubic meter when shrinkage happens. We are not going to be disadvantaged, and then we end up underpricing things. So we don't want to be disadvantaged in the project, so we have to account for that. Otherwise, it's going to be costly to the contractor or to the estimator, whoever is going to be working on that. But the estimator usually will be doing it for the contractor, so it will be costly to the contractor if that is not accounted for, because it will happen and you're not ready for that. So you have to be ready. So that's basically what we're supposed to look at. That's how we then come up with the rate. So this is the rate for the concrete 20 MPa target strength. I hope you have enjoyed the video. I didn't intend for it to be very long, but for the sake of people to understand where these things are coming from and going, you can visit this video, because I've explained things in their stages and bit by bit, so that you get to understand all the nuggets. And make sure you understand where these variables and all these quantities and all these rates, where they're coming from and how they apply in each and every case, because we don't guess to just say, okay, we're going to be using dollars per hour, or we're going to be using cubic meters per square meter, or we're going to be using dollars per kilometer or pounds per kilometer. No, we have to understand where it is coming from and where it is going. If we need to change from this currency to that currency, you also need to factor in that there is a pound per hour, there is dollar per hour. You need to factor in all of it. So you need to know what you're dealing with at each and every stage. So I hope you have understood as you were going through the stages. If you didn't, make sure you revisit the video to understand that. But that's basically the basics of rate build up in construction estimates, how we estimate in the construction industry. So I hope you have enjoyed the video. Make sure you just like the video. If you want to share with those in the construction industry for their edification, for their benefit, that will be better, and that will help people to get to understand these things. Those who are studying construction related programs, I hope this will be for your betterment, for your skill in terms of estimating and also understanding where these things apply, so that you won't be confused in the exams or in whatever you're going to be doing. But that's basically it from me. I hope you have enjoyed the video. I hope we'll continue to estimate the correct way accurately, so that we don't end up cheating each other. And also for the sake of the clients, whichever client in the present day who is a client and dealing with these estimators, make sure you also get to watch this video again and again to get to understand where these values are coming from, so that you won't get cheated as you are working there. It's all for the sake of integrity of the professionals in the construction industry. So cheers till we meet next time. Thank you for watching.